Having some technical difficulties getting fired up. What's happening, everybody? Hope everybody's having a fantastic whatever day you're watching this. So, with so many new engine configurations, designs, engines going away, there's a lot of folks talking about and leaning on this technology that it seems like we're getting bombarded with these new engines. Turbocharging, variable camshafts, variable cam profiles. All of these types of things you would think are new, innovative. But the reality is that so much of what we are being told is something new is really something more along the lines of, well, it's old ideas just with new deployment, if you will. There's a lot of things that are out in the world that you might not realize are actually really old technologies. Matter of fact, some of the earliest engines would employ some of what you would expect today would be innovative overhead camshafts and the like, forced induction, all of that extremely old technology. It's only now that metallurgy and computers and all of that are making these systems more refined, maybe more efficient. But even with, you can't even say efficient though, because there's so many things that had worked out so well with very rudimentary technology. So, what are we really talking about? Well, first of all, we got to look at, well, modern engines. What are we talking about? The V8 is going away. We all keep hearing about that. Why is it that a six-cylinder is a better alternative? How is it that a six-cylinder with a turbocharger seems to be the better choice than a V8? Well, the thing is that it's not necessarily so. A properly tuned, a properly cammed, a properly fueled V8 going down the highway is not really any less efficient than any other smaller engine to propel something through the atmosphere. Where you start to run into efficiency differences is with friction. Larger engines have more ring surface in the cylinder. That's where the friction is coming from. It's really not in the idea of crankshaft or bearing journals, things like that. Matter of fact, a V8, depending on its architecture, could have less actual friction surfaces at the crank than an inline six-cylinder. But the idea really is that it's a frictional loss through the ring pack. So what does that have to do with old is new or new is old again? Well, the thing is that V8s have been around since forever. And the reason why they're going away, presumably, is really only because of the extra power that it takes to overcome the friction can be translated into torsional force on the crankshaft. And that's it. It's just an EPA play. The power requirements to move X mass through Y atmosphere at Z speed is the same regardless of how large the engine is or isn't. It takes 35 to 50 horsepower to move something through the atmosphere at 50 to 70 horsepower or 50 to 70 miles per hour. That's just the way that it is. How you develop it is a different story. And I'm just setting the table with that to let you know that all of the things that make a modern engine efficient, fuel injection, dual overhead cam, being able to rock cams forward and backwards, and all of that is extremely old technology that in many cases harkens back or has its roots well over 100 years ago. So why aren't we there now? Why is it that the American V8 has been a cam in block design for so long? To give you guys an idea with just how antiquated a V8 cam in block Hemi head is, the very first engines that would power anything of any substance were Hall Scott V8 engines that were Hemi combustion chamber because, well, we'll get to the because here in a minute, but Hemi combustion chamber, but those engines were overhead cam. It is a simpler way to make it work. And by the way, these didn't have timing chains. They were actually gear driven, or at least in this case, bevel gear driven. It's pretty interesting. It's a shaft on both sides about that long, and it's a bevel single shaft, and it goes straight to the camshaft. It looks like if you could imagine what the inside of a differential would look like if it only drove one side, that's what it was. And extremely reliable, extremely robust. But in those days, you didn't have to turn the kind of RPM that we do today. But if you were to ever see something like that, you would think, oh, wow, that is super trick. When the reality is that it is some ancient technology. And from there, it moved to gear-driven camshafts. When higher horsepower or higher RPM, higher dial-up rates came into play, the metallurgy just wasn't there from a torsional standpoint for the shaft-driven cams, and so they moved to gear-driven camshafts. So yeah, that race technology, that was just how things were done back then. It wasn't until later when the economies of building engines started to really step into play. So what gives? Why did we have a Hemi back then? Why wasn't it a wedge head? Hemis are just easier to make. Hemi heads are super simple and they're effective. To be able to get air into a cylinder and move air into the cylinder and then consequently get it out of there, from a volumetric efficiency standpoint, the Hemi cylinder head is the best. The valves are completely unshrouded. That's the reason why it's better. Not because one side in, the other side out. The air doesn't know how it's getting in and out. It's the fact that the valves, because they are canted at an angle, they're not shrouded. So it has better flow in and out. With the downside being that, well, from a thermodynamic perspective, it's not as good. The kernel has to, in other words, the spark, the kernel, when it goes off, that flame front has a much larger volume to accompany or to accommodate before it starts to build cylinder pressure. That would mean you have to have dome pistons, means the piston's heavy, and you've got a lot of surface area up top. You can see where this is going. It's not a good efficiency play, but it's good for making something go round and round and burn a fuel. But none of that is new. And so you're being told that a lot of this new stuff is newfangled, but we've had variable camshafts. This is stuff that's been in the works forever. What we don't see are pneumatically powered valves or hydraulically powered valves through a solenoid system. This is a system that, if you think that variable cam and VTEC is cool, this is a F1 was just actually kind of getting into this with pneumatic air-powered valves, but this is a literally infinitely adjustable valve actuation with no camshaft on the engine anywhere. All you have is solenoids that sit on top of the valves, and the computer does all the thinking for it. So the brains of the engine, the camshaft, get removed, and the brains of the engine, the ECU, manages all of the opening and closing of valves and all of those timing events. You can literally tune an engine per cylinder temperature. It's pretty crazy stuff. But this is all technology that was getting played with about 60 years ago. It just didn't ever make it to the party in terms of modern vehicles, primarily because, well, they didn't have the drive systems to make it work, or at least they didn't have the drive systems to make them work reliably. And they still don't, or they would have them in modern engines. And this is one of the reasons why the internal combustion engine is, well, it's some of the evidence that shows that the internal combustion engine is at its limit in terms of efficiency. There's just not a lot left you can do to an engine with technology that really hasn't moved forward since in the forever of the engine being developed. There is no engine design that is any better than the Otto cycle. You can talk about Atkins cycles all you want, but the reality is that from a power density point of view, the Otto cycle, intake, compression, fire, exhaust, suck, squeeze, bang, blow, there's nothing better than that. Gasoline is the best at turning, at being able to be a volatile enough fuel, but is yet stable in terms of carrying it. And then the rapid thermal decomposition of hydrocarbons, basically the burning of fuel, is an incredibly efficient and energy dense fuel. It can't really get any better than what it is already. So manufacturers play around with different fuel delivery systems. Obviously, we've gone from carburetor to fuel injection to direct injection, all that, but the diesel guys have been doing that since there was an engine to talk about. That's really the only way you can make a diesel reliably work is with direct cylinder injection. And so they've been dealing with this since forever. Fun fact, by the way, the original diesels were, well, the attempt was to run them on coal dust. It's just that it was a little bit too volatile and it hard to meter. That's why diesel fuel got so popular. But I digress. When we're talking about the technology that it is taking to make these engines as power dense as they are, what you're running into is a fuel quality issue. We simply don't have the fuel quality that we need to get engines more efficient. It's the knock threshold that you're up against. It's not cylinder head flow. It's not camshaft design. It's not fuel delivery. At this stage of the game, the key issue is going to be how much octane do you have to play with, and how much compression ratio can you work with. The higher your compression ratio, the more efficient your engine. Well, right up until the point where it pre-detonates. But pre-ignition is just part of the problem. The real issue, again, is the why behind it. And it's just odd that people don't want to run their cars on premium or E85 all the time. So the alternative to that would be, well, you've got 104 or 110 unleaded octane fuels at your local pump. And realistically, you don't need it. And I guess here's the reason why you don't see that. Even though those types of fuels would aid in efficiency, the reality is where most people drive their cars, those cylinder pressures don't require octanes that high. It's only when you are pushing that engine where you need the octane to be there. But the reality is that most vehicles, if they're tuned to run on 87 or 89, or at least they will cope with 89 and 87 octane if they're a higher output engine that's more or less designed to run on 93, well, the only reason why you have to run that is because of the peak power output. But everywhere else that engine is running, provided that, it's not set up for maximum brake torque at cruising RPM, you just don't have those needs for the higher octane. My argument is if you're making gasoline, you're making gasoline, right? I mean, it shouldn't matter to me. Like, what's the difference in true real cost between making 87 octane and 93 octane? And why is it that we just don't have 93 octane across the board? That to me has never really made sense. I don't have a cost breakdown or a cost analysis of what it takes to make fuel. You guys might know something that I don't there. So if you do, please feel free to share it with the chat. But I just have never been able to understand why 87 octane even exists. I mean, even going back to, the 80s and 90s where engines weren't quite as efficient as they are today from a fueling standpoint, 87 octane was not good stuff. Lots of issues with 87 octane. So again, that's always been a curious thing. But if you've ever wondered about the technology that you're working with today, Noab, thank you very much, man. I appreciate that. Appreciate the contribution, my friend. I didn't see a question in here. Oh, there he is. What's up, B? Oh, I got the flex. Thank you, sir. But thank you, brother. I appreciate that a ton. Anyway, if you've ever wondered where some of that technology comes from, the reality is that it's been in the aviation industry and on the military side for forever in some way, shape, or form. There's always been an overhead cam. There's always been 4 valves per cylinder. There's always been unique cam drives. There's always been some kind of fuel injection. There's always been some kind of boost. And there's always been the need for a higher octane fuel to make higher performance things work. The big twist, though, is that all of that can seem like it's expensive. But I think with the economies of scale, we found like Ford, everything Ford makes has 4 valves per cylinder and overhead camshafts. There's a couple of holdouts on this side of the pond, so to speak, in the United States, where you've got the Gen 3 Hemi variants and you've got the LT, LS, whatever you want to call it, variants. I guess now it's all LT, but those are really your only 2-valve engines that are floating around out there. Everybody else has gone to 4-valve because it is every bit as, here's where 4 valves are better than 2. They are every bit is volumetrically efficient as a Hemi because technically it's a Hemi. It's a Pentastar cylinder head by design. That's just what you get when you have a 4-valve cylinder head arrangement, is a Pentastar design, which is a modified Hemi design. But you get all of the benefits of the volumetric efficiency, but you also get all of the benefits of being thermodynamically efficient the way that a wedge head is. You get to have your cake and eat it in that respect. So from an efficiency standpoint, it's a big deal to have 4 valves per cylinder. But I guess the bottom line here is we're coming into an era where the V8 is, for all practical purposes, going away for Mopar. And you're seeing Ford as really being the last of the holdouts, with Chevrolet kind of hanging in there with the Corvette, but we all know where that's going. If they do hang on to the Corvette, it will probably have a 4-valve configuration moving forward at some point. There's just no sense in trying to hang on to a 2-valve engine anymore. I think the grip strength of that has started to wane quite a bit, and it's not going to be long before that thing just finally falls. But when it comes to the why behind the 6 cylinders and the turbos and everything else, and why is it that the V8 can't move forward, it is simply because of steady state efficiency. If it only takes 50 horsepower to move something at a highway speed, whatever that is, and you can do so while burning 1% less fuel, then that is an economy that you can take advantage of. And that's where the 6 cylinders come into play. Where they don't do you any good is once you start needing more power. It takes more power to make the same, or I'm sorry, more fuel to make the same horsepower in a boosted application, typically once you start getting into high load conditions. So everything that we were just talking about, all the older technology, 4 valves per cylinder, boost, and all these other things, well, when you can incorporate that into an engine that is at steady state more efficient and at maximum power as powerful or more so than those V8s, then that's the direction you go. But I get it. A lot of guys aren't really big fans of the 6 cylinders. They don't believe that the extra boost and the extra the extra demand on fuel systems and everything that comes with that is really worth it. But here's the problem with how you feel. It ain't about your feels when it comes to the results. And as it stands, Ford, with their 2.7 liter, arguably the best engine that they make, the 2.7 liter EcoBoost, the 3.5 EcoBoost, the 2.0, the 2.3, basically every one of their EcoBoost platforms, except for maybe the 1.0 because it keeps eating oil pump belts. But everybody else in the mix, I don't think that's a belt problem either. Anyway. Every one of these other vehicles that you're going to see coming from Ford is going to be, except for the Coyote variants, is going to have an engine that incorporates every bit of the modern technology you can throw at it. That includes oil pumps that are driven off of belts, dual overhead cam, variable camshaft intake and exhaust side, dual fuel systems, extremely free-flowing intake manifolds, the whole bit, and that will bleed over to the Hurricane 6 coming from Dodge. It's got all of that. But what I'm getting at in terms of your feels don't matter, guys, it's been proven over and over again that it doesn't matter what the engine sounds like if that engine that sounds like a six-cylinder is making more power. Journalists don't care about the noise. They only care about the numbers. And when it comes down to it, the Hurricane 6 versus the Hemi, well, how does it break down? Well, here's the problem. It's more powerful in every measurable metric that you can deliver. And so because of that, well, you're going to get a six-cylinder with a turbo. But how does that equate? Well, it's kind of hard to say, but 3 liters plus basically 2 bar of boost, well, that's 9 liters of actual power producing air that's being used. 1 liter at atmospheric pressure and 2 liters at boosted pressure. In other words, an elevated. So if you want to reduce that and maybe pull some of that number out because of temperature variances, well, okay, let's say it's 2.5 atmospheres worth of actual usable air. Well, 2.5 times 3, that's what is that? 7.5 liters worth of displacement. 7.5 liters is greater than 5.7 or 6.4. And if you drive any one of these vehicles, you'll find out, talking about the Hurricane boosted engines, 6 cylinders, you'll find that that number really does play itself out. They act like large displacement engines when you put them under heavy loads. Not something that an atmosphere engine just can't hang with. So, I mean, I'll put it to you another way. When's the last time you saw a naturally aspirated engine winning any of the roll races or any of the like Texas 2K or something like that? You just don't see that very often. It's because boost wins the argument pretty much 90% of the time. So anyway, the point is this: what's old is new-ish again, I guess. And with the number of innovations in metallurgy and just the sheer computing power and the ability to manage the engine as well as it does, I get it. You would think that you could make a V8 work, but unfortunately, everything you can do to make a V8 work, well, that makes something with boost work also. You can say, well, V8 plus boost. Again, you run into the efficiency issue at steady state cruise. All of these things make a difference. And when you're talking single digit numbers making all the difference in the world for some manufacturers, that's why they've moved away from V8s. And it's a real shame too, but I guess for me, the way I look at it is all of this technology that I'm familiar with just from, studying so much on the aviation side, it's kind of interesting to see it employed in a new way and to have an understanding and the reason behind the why behind some of that technology. Because if it weren't for the old is new technology that you have now, if you're only building and driving engines down the road based on what a bean counter would want to put together, we'd all have flatheads. So like your lawnmower. Actually, my lawnmower is overhead valve now. Interesting. Anyway, let me get to you guys real quick. Behemoth is in. What's up? Ryan is in. Red Dog. David's got the thumbs up. Jebediah is saying, what up, Mason in chat? What up? Behemoth, the old ideas first deployed in motorsports. Absolutely they were. Hard Rock, hello. No Ab. Again, thank you, brother. What's up, B? Brent is in. Red Dog finally got an H-pipe cat back along with my long tubes on Red Dog. And man, does it sound good. I bet it does with that H-pipe. Hard to beat the sound of an H-pipe. You can't beat the sound of an H-pipe. Itch is in. Good day, sir. Good day, Itch. X is in. Sounds like your description of the Koenigsegg free valve tech. There's no cam, just solenoid that opens and closes with the valves. Wonder why this tech hasn't taken off in all manufacturers. Too expensive? Maybe. Here's the funny thing. I'm reminded of, and I know I'm not dreaming this up, there was a 2.3 liter Ford 4-cylinder. And the way that I remember this was that it was a pneumatic system, and it's the 2.3 liter two valve. It was like people would think of it like the Pinto motor basically. And in development, it made like something like 200 or 180 horsepower, something like that. I can't remember the exact number. This is going back, like I'm trying to remember. This is like 20 something years ago. Anyway, it was a proof of concept engine. And the idea was that you can either through hydraulics, maybe that one was hydraulic. I think that one might have been hydraulic. Anyway, the idea is that, yeah, you do not have a camshaft. And based on load, throttle input, and RPM, you have, in other words, you can have a camshaft that acts like it's incredibly advanced with very short lift events, with a camshaft with a lobe separation angle of like 92 degrees. Like it will act like that. And then you rock the thing backwards and you start to open it up and you adjust your center lines and everything for your RPM and your load demand. And so in essence, you can have a camshaft down low that has the cam load profile of a diesel engine that just makes gobs of torque down low, just as you're at cruise or barely into tip in. But you can make the cam scream or make the engine scream up top by giving it a cam profile that would be very retarded, meaning it's drug way back. You've got a very wide lobe separation angle at that point. You're trying to make as much power as you possibly can, reduce all your pumping losses. That's what you can do with that type of an architecture. So it's crazy. I mean, you can do so much with it. It's extremely efficient use too, because you have none of the parasitic loss that the cam will bring to the table. You have none of the failure points that a cam would bring either. So all of these things are bonuses. And the sad thing about it is that we do have the technology to make it work. Now, you want to talk about being a calibration engineer and having, I mean, dude, that's a field day for somebody to be able to put that type of a system together. But it's obvious you can do it. And I believe Koenigsegg did do that with their system. So, just some food for thought. I mean, this is technology that's been in the works for forever. It's just the deployment of that technology, it costs a lot of money and it's extremely time intensive to extrapolate the most out of it. But when you think about it, I mean, you can literally build an engine that will, a small displacement engine that could, at this point, rev to the moon and have torque down low the way that an engine that would only rev to 2,500 RPM could have, right? So it's pretty amazing stuff. And that's really the only technology that doesn't stem from something from literally 100 years ago. And again, with the only real differences being in metallurgy to be able to handle heat, and some design differences that would aid in efficiency for the turbocharging or supercharging. Arfos, what's up? X is in. Yeah, Noab, thank you very much, man. Skids is in. Yo! No, I was saying no question. Vincent, can your Scat Pack or Hellcats lose a bit of power when you floor it from a dead stop without letting RPMs build up? I don't understand the question. No, they're not going to lose any power when you nail it. They're just not going to be able to put any power to the ground because it's going to convert tires into tire smoke. Clay's asking, Forge 5.7 with 6.1 crank, stock bore, and Hellcat supercharger. Make good power reliable? Well, you don't really need a 6.1 crank. The 5.7 crank would be fine. Go forged rods and forged pistons. Hellcat supercharger? Yeah. Yeah, I mean, it wouldn't be a bad combination at all. Brent, thank you very much, man. Saying nothing was as fun as the Buick Grand National, the T-Bird, or even the Turbo 5.0, the Turbo TA, yeah, of the 80s. Should have stayed with the turbo cars back then. Fast, fun miles per gallon. So here's the funny thing. You want to talk about a crazy design. A lot of, well, all of the supercharging systems that were like that back in the day. The Turbo TA, the 301 with that turbo, it was a draw through, and it was crazy because the carburetor sat on top of this pad that fed the inlet side of a turbocharger. Not, I mean, and there it was not intercooled or anything. I mean, it went from there right into an intake manifold. So you're taking a turbocharger that's spinning at, I think that one spun at like 70,000 or 80,000 RPM, and you're just beating the crap, or it's getting its ass kicked by the atomized fuel. I mean, it anyway. That system would have been the same in terms of familiarity. That is like World War II technology, just without the 4 valves per cylinder. But that's exactly how those engines were designed to run. And it always blows my mind that they held together. But the intake, the impeller side is just real beefy to handle literally dealing with the mass of the fuel that it was hitting. Oh, Skids, Chevy did do another dual overhead cam in the Z06. Don't know all the ins and outs, but it doesn't sound Chevy. Not a big fan. I'll tell you this: I haven't really been messing with the Z06s, but I know they run good. But yeah, the T-Bird was great. The Grand National, yeah, those were fuel injected, but yeah, the TA. There was a TA with a Grand National engine, but yeah, all really good stuff. But thank you, Brent. I appreciate it. Vincent, do I miss my Hellcat? No, I do not. Ryan, yeah, the old Conquest or Shelby Daytona, dude. Yes, please, both. From the 80s, fun too, pretty quick. Omni GLH was good. The Daytona GLH was also really good. Those were cars that would embarrass guys with V8s. I mean, it was a driver's race, no doubt about it. Those old cars were fast. DM, good evening, chat friends. Good evening, DM. Brent saying very true. Vince, is the new GT500 a better all-around car than the Hellcat Red Eye? No, it is not. Clay, nice. Thank you for the answer, Low Channel. Thank you so much. I appreciate that. No, Vince, it's not a better car all the way. If that car had a true automatic transmission, you wouldn't be hearing me talking about Hellcat stuff. I'd be talking about GT500 stuff. If that car had the 10R 140 in it, which is a transmission, you have 10R80, 10R 10-speed automatic, like a true honest to goodness automatic. That would be what it would take for me to get back into another car, or what it would have taken to get me back into another car. I have a forever place in my heart for GT500s, Mustangs, things like that. But no, when they went with that DTC transmission, on the surface, it does really well, right? Like it does some things exceptionally well, but the problem is that it doesn't scratch the itch for your enthusiast that's out there. The enthusiast wants either a manual transmission or a true automatic. The problem is when you get into these, the DTC, basically the hybrid style transmissions, there's a lot of complexity. There's a lot of things that make them work exceptionally well, no doubt about it. But to get them to work that exceptionally well, you end up wearing the hell out of the clutches. And so there's guys that have Lambos or other higher end sports cars that do run into issues with those things. I'm surprised that the Vet doesn't have. I think the Vet's got the most refined transmission, and I think that it's the best out of all of them. But for the Mustang, guys wanted something that was a bit more like what they were used to, primarily manual transmission. But even at that, I still wouldn't be a player anymore on those. Um, so again, one burnout competition you saw back in the 90s, a Grand National won the whole thing. I don't doubt it. There was a guy down here that had it was an AMX with a Grand National swap. That thing was fast. It was a high 10-second car. It was lime green. Thing was hauled ass. Um, let's see. Actually, I'm just not sure how appealing the i6 is to the Mopar crowd. I think if people want an i6, they'll shop BMW, Toyota, or anyone else. I think people shop Dodge because they want a big V8. Well, yes and no. I mean, look at it like this. People used to buy Fords specifically for the inline six, the 4.9 liter. The 225 inline six, the leaning tower of power, that was a hugely popular engine for Dodge. I get where the performance enthusiast wants that V8 rumble and all of that, but and I'm with you. I mean, look, I voted with my pocketbook on this. I specifically bought the Ford because it has a V8 and how that V8 runs. It's completely different than the Hemi in that respect. But you have to, unfortunately, we're stuck in a situation where these inline sixes are just that good. I think my only real issue is still going to be, and I'm probably you and I are going to agree on this, is longevity, is reliability. But here's the thing. Before we went on live tonight, I was going down a bit of a rabbit hole. And that rabbit hole was Hurricane 6 reliability, Hurricane 6 problems, Hurricane 6 issues, Hurricane 6 concerns. And it's funny that the only thing that I could find negative about the Hurricane 6, not talking about any other engine, just the Hurricane 6, was rear main seal leaks and possibly, not for the reason you might think, but head gasket failures. Now, the head gasket failures were attributed to overheating, which is a completely different issue, in my opinion. That's a symptom, the head gasket failing, of a problem, which is overheating. But a rear main seal leak, well, that's another problem, because a rear main seal leak can come from a couple of different areas. Bad seal or way too much crankcase pressure, which would be bad ring packs. You can have an engine with a shot ring pack that's boosted, not really smoke, because if it's always under boost, you're always forcing the rings against the cylinder. But you also have issues with blow-by at that point, which the blow-by runs through the PCV system and then back through the intake manifold. See where I'm going with this? So to say that something just doesn't, oh, it's just a leak, it's not that big of a deal. Well, your standard output uses 24, something like that, PSI of boost to make its power. The high output uses 28 or 29. It's basically a 2-bar engine. Yeah, if something goes funky with rings at those power levels, you are going to be pressurizing that crankcase like a spaceship, okay? So, yeah, you're damn right you're going to start having leaks. And, of course, with the PCV system being what it is, it immediately starts fanning that stuff right back into the intake tract. Nobody's talking about that. So I don't know that that's an issue. However, sometimes where there's smoke, there's fire. Other times where there's smoke, it just means something's broke. Vincent is asking, do I think the new C8 Z06 is worth the price or too expensive? I don't know how to answer that. I love the car. I think that the car, if you are into Corvettes and the handling and the sound and all of that, then it is worth the price. But for some people, all of that it's wasted on them. They don't really know what they're working with. So if you use the car and you actually drive it to some extent deep enough into its power band to make it an entertaining car for you, then yeah, it's worth it. The handling is really good. Brent, thank you again, my friend. Saying even the 3.8 supercharged cars in the 90s were fun. Yeah, they were big time. Buick had a bunch of them. There was a hot minute. There was a Buick had them. Mazda had them. The supercharged 6-cylinders. There was a rash of those, and they're actually really good cars. Funny fact too, the Buick 3.8 with the supercharger, the M90 supercharger, is a direct descendant of the Grand National. It's actually a little bit more robust than the Grand National was, block-wise. Ryan saying nothing more awesome than seeing a 4-door Omni that I had beating up on the Civics and some Eclipses and MR2s was fun. The faces were funny too. The 80s, Mopars. I tell you what, man, Mopars were doing some work back in the early 2000s too. Let's not forget the SRT4s. Still one of my favorite cars. Beavis saying, I know you don't recommend turbos for modern Mopars, but did you have any success stories with customers who went with turbos? Seems like they mainly appeal to 1,000+ horsepower crowd with Mopars. So they kind of do. The only reason why I don't recommend turbos is because of the cost. Pites is currently wrapping up some R&D on their own in-house twin turbos for Challengers and Chargers. And it's a clean kit. I mean, it's really good looking. So that would be an option to have something that is bespoke in that it is a in-house clean sheet design. Depending on the cost, yes. But the only reason why I usually would kind of shy against them is typically for cost. Most of the time, though, guys that were messing with any of the Hemis were more interested in either a pro-charged application or it was all Hellcats. It was like 100% Hellcats at that point. So to answer your question, no, not really with the turbos, but that is going to be making a pretty big splash here in probably the next 6 months. And there's guys, look, there's folks that have, gone compound with TRXs, and I get that, but realistically, I'm not going to say the juice isn't worth the squeeze, but again, we have to ask the question, how fast is fast enough? What power number are you really going to be happy with? What power number are you really going to be happy with, and what is going to survive long-term with your car with use, misuse, and abuse, right? If we're talking about a car that is just going to be, you're going to play around with it on the street, realistically, 650 to 700 horsepower to the rear wheels on a Mustang dyno is all that anybody is going to want. I know that, I want 1,000 horsepower to the rear wheels. Yeah, slow down, Sparky. Because here's what happens. 90% of the time, guys would say something like that. Say, okay, are you sure you want that? Do you know what 700 horsepower to the rear wheels feels like? You know what 800 horsepower to the rear wheels feels like? Well, I've got a friend and he's got it. I'm like, yeah, you don't have, your friend doesn't have anything like what you're talking about. And what you do is you just go grab one of the shop cars and go, look, I've got to data log this thing anyway. You're going to hold the computer for me. And you take them on a high load, high RPM data logging extravaganza. And with it, it never fails. The first 2 seconds into that pull, the cabin of that car smells different. Like you can almost set your clock to the way that people they forget to breathe. When you experience something that is that fast, it's somebody's heading out to make his. Velocito is in a very good way this evening. The weather is gorgeous. So greetings from Velocito. So imagine that level of power times 1.3, 1.5, 1.7. People don't know what to do with themselves when you're talking about power levels that are only in the 800 to 900 horsepower to the rear wheels. So like it's a spooky thing when you have a car that will accelerate on the highway 60 to 130 faster than most cars can go 0 to 60, right? So that's really where you wind up, and when you start getting to these really high horsepower, and what I'm talking about, like 600-700 horsepower to the rear wheels, that's a fun street car. Once you graduate past a stock Hellcat, if you want more, okay, fine. If for whatever reason you need more than that, then 600-700 horsepower is a nice, fun place to be once you've got the experience behind you to drive a car with that much power, because now you're at the limit of what reality will allow for you to get away with on the highway. And in other words, how much the tire technology can manage for your weight of your vehicle. What fuel quality can really manage and what it can handle based on the mass of your vehicle, the power that you're making, and all of that. All of these technologies, by the way, stem from math that was done over 100 years ago. See how I tied it in with pretty sweet, huh? Anyway, all that is based on mathematics that had been perfected literally over 100 years ago. But again, modern tires, they're so much better than the tires that you used to have. You can manage more power. That's great. The cars are heavier now. That's in a way a good thing because it helps keep that power on the ground. But after about that 700 horsepower range to the rear wheels, traction becomes more of an issue, especially if you're rolling along at 50, 60 miles an hour and you mat the throttle. If you don't have drag radials, you're going to be hazing the tires, and you don't necessarily, I mean, it sounds cool. It sounds exciting. It's annoying. If I'm going 80 miles an hour and I go to tip into the throttle hard and it starts to haze the tires, it's neat. It's funny if you're expecting it, but it's more annoying than it is anything. That's when having like a Trackhawk or a Durango that's all-wheel drive, that's when having one of those is really good, a TRX, where you can watt the throttle and it will hook and bug, not start, getting a little bit weird and start wandering a little bit in your lane because you're just trying to use the power that you've got. And this is a fun, and I always say fun fact. I don't know where I'm hanging on this fun fact phrase, but where most guys will sell their cars, like they'll do a build and then get rid of it, it's typically somewhere around that 650 to 750 horsepower to the rear wheels that they'll get spooked, but it's hard to get only that power number out of a Hellcat once you start to modify it. So you go pulley Z85 and pumps, and you're at 800 and something horsepower to the rear wheels on a Mustang dyno. That car, you're kind of screwed. And the car is going to be light in the tire. Even with drag radials, it'll light the tires up going 65, 70 miles an hour down the highway. Sounds like fun. It's neat for about 5 minutes, and then after that, it's kind of worn out its welcome. So anyway, that's where we're at with that turbo thing. They're great. They're efficient. The turbos are going to be the best cheat code because at any altitude, you can make the same power too. Lime's asking, okay, how about an i8 4-liter with the same technology as the i6 3-liter they're making soon? Would that give you better sound, more power other than size? Any problem with that? The only issue you'll run into is why you don't see a lot of straight eights anymore. They were popular in the late 20s, like literally 100 years ago, early 30s. The only problem with the straight eight is in the torsional deflection of the crankshaft itself based on the diameter of the actual journal. So the problem is that the longer your crankshaft is, the more deflection you'll have from one side to the other. So if I'm applying power over here, or if I have load over here, that is not going to be evenly transmitted through the crankshaft. And to get that crankshaft to be more stiff, you have to do two things. One is you can make it bigger, but in conjunction with that, you're going to have mains in between each and every one of the two, well, at least every 2 cylinders. So you need to have 4 full mains, or if you separate each one, that would be even better, but that would be a lot of potential frictional loss. So you've got some, and that's basically just from the fluid tension of the oil on the mains. That's a minor thing. But again, anywhere that there is a load on something that you're twisting, the longer you have, the more torsional load you're going to get, or torsional effect you're going to have based on any load. So that's why straight eight's not so much. Like a small straight eight though. So instead of a 4-liter, if you compare that down to maybe a 3 1/4 or a 3.5 liter straight eight, maybe in that type of a configuration with basically large journals and individual main caps throughout the entire block, that might work. But then again, you've got now more mass, more length, and now it turns into a packaging issue. So that's why on the straight eight route, that could be a potential issue. My thought on that is, why 3 liters? For me, why not just make an American Barra and make the thing 4 liters and have it, cap out at maybe 6,200 RPM? You don't need much more than that, and you can make that work, and it's going to be a well-balanced engine. It's going to do well. So for me, I'm just kind of weirded out by the 3-liter displacement thing. You could have gone a little bit bigger and probably done a little bit better, in my opinion. Vincent, what's more popular? Lamborghini. What's more cared for? Ferrari, hands down. Easy answer on that one. People treat Lamborghinis like they're disposable. Ryan saying, Menace in the 80s, they were popular with some turbo engines, not big V8s except in the trucks. Oh, we're talking about Dodge. Yeah, they were a lot of fun in the 80s. Itch is asking, is there an aftermarket kit that you know of or could recommend you can purchase for a 6.4 that will give you all the required forged upgraded parts to handle higher boost? There were a bunch of them. You had MMX had a forged internal upgrade kit, had Molnar pistons and rods that were just, you could get the drop-in kit with the factory bore sizing, or you can go 10 over if you're going to have your engine machined. But that's really all you need. The crank is already there. All right, saying, oh, the Neon SRT4, yes. Crossfire was cool too. Yep, SRT6. Turbos. Okay, so to answer your question, Vincent, it's not turbo. I never said turbos are better than superchargers. Turbos are a cheat code in that they are more efficient, but efficiency doesn't mean better. And efficiency in terms of outright power production doesn't translate into a driving experience. A supercharger is instant right now, snap of a finger power. Turbos aren't like that. They do have to spool up. If there is an Achilles heel to turbos, It's that you are limited in instant power with them by the size of the turbo, which would then limit your total power production. So, um, but no, turbos are not necessarily better. They are better at being more efficient in making power. And if that weren't the case, then every big rig that you see would be running a supercharger, not turbocharging. But the reality is that the reason why they don't run turbos is because people don't like driving turbos as much as they like driving supercharged engines. Supercharged engines give you instant power, and it makes the engine that you're driving feel much larger at basically right off idle. They also work much better from a packaging standpoint. It's just easier to bolt on a supercharger the same way that you would bolt on an intake manifold, as opposed to all of the plumbing that you have to route for the turbocharger itself. It's a packaging issue. It's a packaging nightmare in some cases. Red Dog, yes, it was. The Crossfire was a Mercedes. Oh, hell. What was it? Yes, it was a Mercedes, though, for sure. Right, nostalgia. But thank you again, Brian. I appreciate it. No way I say my car should be rolling this weekend. It's been since August 25th when she broke. It'll be the first time driving it on that last tune. I went with a new 309 and new axles, dip brace, cradle lockout. Very nice. Looking forward to hearing about your success with that, my friend. Ryan saying, yeah, it was neat that it was still in Mopar clothing. Yep. Oh, Skid saying Stellantis is laying a bunch of people off right now. A bunch of layoffs the other day. No admission that they screwed up with Dodge. We may have a problem with people not buying our cars here. Yeah. Well, they keep giving us reasons not to buy them, don't they? Oh, X saying in the Toyota community, yeah, a lot of people are upset about going from V8s to these four-cylinder hybrids. Toyota V8s are known for 500,000 miles easily. Yeah, that's the reason why I didn't get a Toyota. It's the reason why I bought the Coyote, is because the Toyota, I couldn't get a V8 anymore. And I get it. It's not as powerful. It doesn't do that. That's okay. But they are and have been known to be reliable. So there is that. The Lexus IS 500 exists. They need to have the 5.6 back in those things. Can you, wait, I think Nissan, I forgot all about Nissan. Hey, Chu saying, I don't think Stellantis will have many problems with the Hurricane engine. There are several European cars in their lineup that have been using turbos for decades. Oh yeah, no, there's not going to be an issue there. The people that are concerned about the amount of boost per horsepower the thing is dealing with. But I doubt that they're going to have any real issues with it. I say that. Any engine, anything that runs on, any machine can fail, right? Any kind of machine can fail. The problem is, making sure that everything works great in a laboratory too. You put it on a dyno, you stress test it, everybody, huzzah, cheers, bully. But the problem is that what works in a laboratory and what works on the dyno does not always translate into the real world. In fact, I would say about 70 to 75% of what works on a dyno really does translate into the real world. And these are areas where, look, when you have to be able to test these engines and stress test them with horrible fuel, with high temperatures, with bad oil, with low oil, with all the things that can go possibly wrong. You need to be able to test them under those conditions. And I'm sure that they do. Use, misuse, and abuse, blah, blah, blah. But you've got to have that level of data to be able to back up what you're warranting. Part of what comes to mind with that, Live, thank you very much, man. Saying thank you for answering my question, brother. Thank you so much for that. part of, so let me give you guys an example of what I'm talking about. There are folks that have a there is a lot of folks that have an aversion to these belt driven oil pumps. One of the issues that I don't have with belt driven oil pumps is that in any latest iteration of these high performance engines that we're working with that are now commonplace, and I say high performance, I'm not talking about, a Scat Pack or a Mustang or something like that. I'm talking about these small engines that make a ton of power for their size. They need every NVH reducing contraption or tchotchke that they can come up with, because at those power levels and under those loads that you'll see, those loads and any vibration or anything like that is translated into other components. It's the reason why you have premature oil pump wear. It's the reason why you have some Ford oil pumps coming apart, Chevy oil pumps coming apart. There's a lot of goofy stuff that can go wrong. And so in the effort to mitigate NVH, to increase efficiency, manufacturers go to these parts, belt-driven cam drives, things like that that are immersed in oil. The reason why they do the immersed in oil thing too, if you've ever wondered, is when the vehicle comes to temp. First of all, you have to remember these are not tensioned items, and for the most part, they're guided, but they're not really tensioned. They're not tensed. But the idea with having an oil bath is that once the engine gets to operating temperature, there are no variations in the internals realistically, unless it's undergoing some kind of a real issue, heavy towing or low oil conditions or whatever, where you're spiking the oil temperature. The idea is that you have a constant temperature that you're working with for that particular part. And as such, and as something that is not metal, it doesn't deflect, it doesn't stretch, it doesn't have all the issues that metal can have. And it's a more consistent drive torque on whatever it's on. It's one of the reasons why large cruiser motorcycles have belt drives instead of chain drives. All of this stuff comes into play, right? So I look at that as a good thing. I'm like, oh man, my 5 liter's got a belt-driven oil pump. Sweet, because I know about that from the racing community where you use belt-driven dry sumps. And that's a huge good thing. I mean, you want that. But a lot of folks freak out about that too. And that ties into, older technology where, you had, if it wasn't a splash bath oiling system where you're just relying on something splashing around in the oil to lubricate itself, your high pressure oiling came from external pumps. So yeah, I mean, again, it's what's old is new again. Hey, fun fact too, here's another, every time I say that, so you got to do a shot. The Model T had a crank trigger. The Model T had individual packs, coil packs and all that kind of stuff. A lot of fun old stuff out there can still be attributed to some concepts that are, again, incredibly old. Hang on just a second. Let me get back to where we were a second ago, guys. And we're coming up. I got about another 4 minutes, guys, and I got to bounce. So I want to make sure I get with you guys as many questions as I can before I have to run out. Oh, hang on. Skids, are any of Stellantis brands known for reliability? I don't know that they are. People saying even in my slow RT, it doesn't even take more than a few seconds on the throttle before I'm doing sketchy numbers. RTs are not slow, but I know what you're saying. I'm telling you, man, some of the stuff that I've driven is like sketch level 3 a.m., man. I'm not kidding. And this stuff, and I'm not one to say that I've driven the fastest cars. No, I'm telling you, I know what it looks like from the point of view of around 1,000 or 1,200 horsepower. there's stuff that's lurking around out there that's double plus that. So yeah, if you think one is 1,000 horsepower is nuts, yeah, 2 or 2,500 is where you need to even be remotely competitive in some of the 2K stuff. Jeez. So Skid saying, so I was trying to see if you could build the new 2025 Ram, either Lone Star or Laramie with the HO 3-liter. Spoiler alert, not at this time. The cheapest one with the HO was 80 to 82. Bloody no. Are you serious? On Ram's website, yeah, it just makes me curious what the HO Charger models are going to start at for reals, right? Stuart, Mopar. Absolutely Mopar. Brent saying the new 25 Ram price is nuts. That's what it sounds like. For the top of the line when I saw 95 large, get out of here. Are you serious? Brent saying, I bet the HO Charger will be 60. I'm hearing 70. If it's 60, bro, that's a good deal. By the way, and I can't show you, I was looking at, I don't think it's a dark horse. I think it's just it's just a GT, I believe. Anyway, at the Ford dealership, $63,000 whole ass dollars for a Mustang GT. I don't think it was a dark horse. Skid saying, saw that one as well as a tungsten. Have to stick your pinky out when you say that for sure. Yeah, you would. Good night. That's a lot of dough, bro. 80-something K? Why? Why is it 80,000 fucking dollars, man? Like that's some bullshit. I mean, a $60,000 or a $70,000 truck is too much to ask. But 80, like, good grief. HU say perhaps a Hurricane being 3-liter is Stellantis want to sell cars in Europe. And you're right about that. There is an added tax for the larger displacement, but I don't know, man. Yeah, I mean, that's what I was hearing too, Skids, with the cheapest HO trucks being 80-something, the Charger. I mean, I'm guessing 70. Well, I heard 70,000 was the number. So if it shows up and it's around that number, you heard it here first. But that's my understanding is that's the number. Brent saying, good point. Yeah, still a 450-ish standard i6. I mean, it's not going to be slow. And again, Lime, thank you again, buddy. I appreciate it. But with that, guys, I got to wrap it up. It's 9:30 my time. I've got to get back to work. But guys, listen, I want to thank each and every one of you guys. Man, I really do. Noab, Brent, Lime, I appreciate you guys a ton. Would not do this without you guys. Love each and every one of you guys. Get out there and do something cool for somebody. Chances are they need it way more than you know. And with that, guys, I do have to wrap it up. Thanks again. We will catch y'all on the next one. That's a wrap. Adios.